Now we're going to give you some applications on exponential functions. At the beginning of the tutorial, I told you that this chapter is very important in all science fields. So let me show you that by showing you the sort of applications you get. This applies to biology, where you're talking about bacterial growth, and it applies to physics when you're talking about radioactive decay. It applies to normal life when we're talking about population growth. It applies to economics when you're studying what happens to the market, etc., etc., etc. It's very important, and we're going to go through all that again in C4 when we're talking about integration. But for the time being, let us take an exemplar application on exponential functions. So here in this question, we are given that we're talking about the price of a car. As I said, it's important in the market. So here we have our very amazing pink car, and we're studying its price, how its price depreciates with the years. So we're given in the question that our price follows a certain formula, and this formula follows an exponential decay. So let us see what this formula is. First of all, we're told that the car follows the formula where we're talking about price equals to 16,000 multiplied by our natural number e to the power negative t, why isn't the t writing? Yes, divided by 10. As you see, it's exponent negative because it's decay. A price of a car depreciates with the years, it does not increase. That's very natural and common sense. So, what does the question ask us to do? And we're told that this is in pounds, by the way, just in case. So in our first part of the question, we are told to find the price when new. So we're not painting, so yes. So part A, price when new. First of all, you know that when we're talking about new things, we mean that our time is 0. It's just common logic. So it's going to be 16,000 multiplied by e to the power negative 0 over 10, which means this will be reduced to 1, and this is going to actually equal to 16,000 pounds. And this was how much the person paid when they're buying the car. Now, if after 5 years they wanted to sell it, what will be the price? This is the second part of the question. Calculate the value after 5 years. We're going to simply just replace again in the formula where we're going to start by our 16,000, then multiply by e to the power negative 5 over 10 or just negative half, and then we will figure that the price after 5 years of this car is going to be 9,704.5. If we know these sort of values, then a person who buys the car or a person in the market knows exactly how much they'll benefit or how much they'll lose with the passage of time. And this is the sort of applications you come across when you're dealing with exponential functions. Now, as I said, this can apply to population growth. You're talking about bacterial growth. It can apply in many, many, many fields. And this is why this chapter is specifically important, because it has many applications, not because of anything else. And by that we're just done with the applications and we can sum it up. So this is our summation, or our, usually it's called our tips and tricks, but there are no tips and tricks here except read the questions correctly and illustrate when you're doing problem solving and etc. So in this chapter, what did we do? First of all, as we said, this chapter is called the exponential and log functions. We're talking about a new type of functions that deal with a curve that increases exponentially. The slope is continuously increasing and increasing and increasing. It is important because it has multiple applications in multiple fields. We knew that first of all, our general formula for exponential functions is a to the power x. Then we spoke about the normal graphs, and we said they look something like this if a is a normal number, and it looks just like reflection in the y-axis if we're talking about a fraction. And then we spoke about that we can apply to it normal transformations that you already know from previous mathematical courses, IGs in C1 and C2, etc. It's very simple and straightforward. And then we spoke, when we were done with introducing the exponential function to you, we explained further there is something called the natural number, and we refer to it as e. It's found on your calculator if you use alpha e. and it's equal to 2.718, etc. And what is special about it is that when you differentiate e to the power x, you're going to regain e to the power x. And this is actually very important in multiple applications that you do not necessarily need to know now, but you just need to know that this is called the natural number. And when we're talking about uh, and e to the natural number, and this is the natural exponent. And then we spoke that like any one-to-one function, uh, uh, the function a to the power x has an inverse, which is log a to the power x. And we said that if we have 2 to the power 3, this is going to be log where the base is still 2, but this is going to be the answer of this, and then the answer of this is going to be the exponent. And then we spoke that when we say log capital, we just mean log to the base 10. And we spoke that when we say log to the base e, we just mean ln. And this is called the natural logarithm. Again, it's a very important function. And I've never mentioned this, so the graph for ln is actually, as we know, it's if this is going to be our function, it's the inverse of it is going to be the reflection in y equals to x, and this will make our graph actually look this way instead. Where again, by the way, this is 1, and instead it's this way, where y is an asymptote, and where y is an asymptote and it's an increasing function, and this is our len or log function. This is the graph for it. It's very important. It applies all normal transformations apply to it and such. But that would be the simple way of covering the logarithmic function. So after we introduced the use of e to the power x and the inverse of the exponential function, we moved on to applications and we gave an example of the car. As I said, it applies in many other fields, and you can also apply len. It depends on the question. They'll give you a general formula. You just have to do some replacements. You have to use your common logic, and this is it for this chapter. It's quite easy and simple to follow it.